Hi, this is Russ Dollinger from Science Glen. I want to go over the molar masses of copper, iron, and lead hydroxides. So let's start with copper. So what do you think the formula is for copper hydroxide? Do you know? What do you think it is? Well, did you ask which one? Because in fact, there's two of them. Let's look at the flashcards. There's a copper 1 hydroxide, copper 1, and there's a copper 2. These are called type 2 cations when there's more than one different charge. Okay? So now let's start with copper. Copper 1, that is. So copper 1 loses one electron. It loses a 4s1 electron, and it becomes +1. Now if we put that together with hydroxide, hydroxide has got an oxygen and a hydrogen grouped together with an overall charge of -1. You can see that, all right? So now if we put these together, +1, -1, it should be straightforward. Let's look at the Ionic Bond Disc Model to make it easy. So we have a copper here, and we have a hydroxide, and these just go together like that. So you get CuOH. Now, if you look at this now, to figure out the molar masses, it's really straightforward. There's going to be one copper, one oxygen, and one hydrogen. And you can see that in the molar mass formula, 63.546 and almost 16 and 1, and it adds up to a total of 80.553. Now, bear in mind, this is with 3 decimal places. Okay, chances are you're not going to have that many, and you may have a slightly different answer, and that's a rounding error. Now, let's do copper 2. So it's called copper 2 because it loses 2 electrons. And you can see that here. It loses 2 electrons. It loses a 4s1 and one of the 3d electrons. Okay? It gets a charge of 2+. Now, the hydroxide is still -1. Now, you see we've got a +2 and we have a -1. That doesn't add up to 0. We always want to get to 0. So that means we need to have something else to cover that. So if we look at the Ionic Bond Disc Model again, now we've got 2 pluses here. Let's get it in center here. We have 2 pluses. And so we're going to need 2 hydroxides. So now if you look at the formula for that, it's going to be Cu parentheses OH in parentheses 2. So now if you look at the formula here for formation of copper 2 hydroxide, you see how that's Cu parentheses OH in parentheses 2, and the red 2 means that there's 2 moles of the hydroxide. So it's 2 moles of oxygen and 2 moles of hydrogen. If you look at the Ionic Bond Disc Model, we got 1, 2 oxygens and 1, 2 hydroxides. So when you add them up, you have to add the molar mass of 2 times 15.99 for the oxygens and 2 times 1.008 for the hydrogens to get your final total. You add all those together and it comes up with 97.560. Now, in a similar way, let's do iron. So what do you think the formula is for iron hydroxide? Do you know? Well, if you thought which one, you're right. Because there's 2 of those too. There's an iron 2 hydroxide and there's an iron 3. Now let's look at iron 2 to start with, okay? So iron 2 is called iron 2 because it loses 2 electrons and has a charge of 2+. Simple enough. And it loses both of the 4s2 electrons. So we have iron 2 and it's got 2 pluses. So we're going to need 2 hydroxides, right? 1, 2. So now looking at the formula for iron 2 hydroxide, you can see it's Fe parentheses OH and parentheses 2, same way. The red 2 means it's got 2 oxygens, 1, 2, and it's got 2 hydrogens, 1, 2. So you add all that together and it comes up to 89.859. Now in a similar way, how many hydroxides do you think would be required for the iron 3? Iron 3 has a charge of 3+. So it's going to need 3 -1s to balance it. So it's going to need 3 hydroxides now. So we could click that together. 1, 2, and let's get another one over here. 3. So now we have, if you count this carefully here, we've got 1 oxygen, 2 oxygens, 3 moles of oxygen, and 1, 2, 3 moles of hydrogen. Now, if you add all those together, it comes up to 106.866 grams. In a similar way, if we do this with lead, what do you think the formula is going to be for the lead hydroxide? Again, there's two of those too. There's a lead 2 and there's a lead 4. That's Roman numeral 4. And lead 2 has got a charge of +2. It loses 2 electrons, both of the 6s electrons. Okay? And so lead 1 and 2. So it's got lead 2 hydroxide. Let's bring that down so you can see. Move that out of the way. Lead 2 hydroxide. 1, 2 oxygens, 1, 2 hydrogens. The lead 2 hydroxide, the lead is pretty heavy, 207.2 grams. Now you notice there's only one decimal place there. So everything down at the bottom is going to be only as accurate as the least accurate. Well, the lead isn't very accurate, and so you keep it to just the one decimal point afterwards, and it adds up to 241.2 when you put all the things together. Now, if we do the same thing with lead 4, let me get my lead ion here. Okay, it's going to lose 4, so it's got a charge of 1, 2, 3, 4. Here, 1, 2, 3, 4. So it's going to take how many hydroxides? You said right, 4? Exactly right. Simple, huh? Okay. Oops, and we need one more. Grab one from over here, and we've got that. So now, if you look at the formula for this thing, you can see that it takes 4 oxygens, 1, 2, 3, 4, and 4 hydrogens, 1, 2, 3, 4. So 1 mole of lead 4 hydroxide has got 4 moles of oxygen at 15.99 grams each per mole, and you multiply that times 4 to give you your total of 63.996, and the hydrogens have got 1, 2, 3, 4 times 4 to give you 4.032 grams, and you add all that together and you come up with a whopping total of 275.2 grams per mole. Lead's heavy. That's how you can figure out the molar masses for these things where there's more than one type of ion. Using the flashcards, which are available on Amazon, and they're doing very well. I think there's a discount right now, and we've got 4.9 stars, and it's doing pretty well. Then the Ionic Bond Disc Model is available from us, Science Glen. It's in production right now. We're finishing up the last little, glitchy details, but it should be available in May. Thank you very much. It really is a joy helping you guys. Thank you again.